Hey guys, so in this video I want to go over lesson 4, and this is from unit 5, not 4. So in this lesson 4 we are going over midpoint and distance. So most of you can tell that from the word midpoint we're going to talk about the point in the middle of 2 points. Now, I'm going to show you the mathematical way to look at this. What I mean by mathematical, I'm going to give you an exact formula that you can use to find your midpoint. And then I'm going to show you an alternative way to look at it. So we're going to do the formula first, we're going to go through an example, and then the second example I'm going to show you the alternative way. So, with the formula, you're going to take your x values and you're going to add them together, and then you're going to divide by 2. You're also going to take your y values, add them together, and divide by 2. So the formula for midpoint is your first x value plus your second x value all over 2, or divide by 2. Then you're going to take your first y value and add it to your second y value and divide by 2. So that is your formula. So if we were given example 1, find the midpoint, and I know it says 2 but it should be 1. If you were given the points -4, -6, and 10, 14, what would be the midpoint? So this is your first x value, this is your first y value, first x value, or second x value, second y value. So to plug it into the formula, we would have -4 plus our second x value, which is 10, all over 2. Then for the y values, we have our first y value, which is -6, plus our second y value, which is 14, all over 2. And then we simplify. So for the x values, -4 plus 10 gives us 6, all over 2. For our y values, we have -6 plus 14, which gives us 8 over 2. And then lastly, 6 divided by 2 gives us 3, and 8 divided by 2 gives us 4. So that would be our midpoint. So that is how we use our midpoint formula. Now another way to look at this, and I'm going to come up here to the top right corner if you have this in front of you printed out. If I wanted the average, and this is not anything to do with midpoint or that formula we just learned, this is just a review, kind of taking you into that alternate way to look at it. If I wanted the average of these 4 numbers, 2, 5, 7, and 8. Hopefully we know to take the average, we're going to take all numbers and add them. Then we're going to divide all of the numbers added together by how many numbers there are. So in this case, we would take 2 plus 5 plus 7 plus 8, and there are 1, 2, 3, 4 numbers, so we would divide by 4. And then we would simplify. So 2 plus 5 plus 7 plus 8 is 22. So we'd have 22 divided by 4, which if you put it in your calculator, you simply get 5.5. So that would be the average of the numbers given. Well, in example 2, we can use that same concept to do midpoint. So if we were given 2 points, and in example 2, we're given a graph, so we have to look at the graph to find our points, starting at the origin going over 1, 2, so negative 2, up 1, 2, 3, 4, so positive 4, and point B is starting at the origin, 1, 2, 3, 4, going up 1, 2. So I want the average of my x values. So I'm going to look at negative 2 and 4. Well, average of negative 2 and 4, we would find it by doing negative 2 plus 4. And there are two numbers that we're taking the average up. Looks familiar? That is how the midpoint formula was created. But if you don't like midpoints, you can just think of it as finding the average of the x values. Negative 2 plus 4 gives me 2, and still over 2. So for the average of x values, my bad, I was looking at the next one, gives me 1. So that would be my x value of my midpoint. Then the average of my y values, well, my y values are 4 and 2, so I'm going to add the two numbers given, divide by how many numbers there are, so 4 plus 2 gives me 6 over 2, which gives me 3. So my y value of my midpoint is 3. So if you will, pause the video and attempt number 4, or technically number 3 example. So you should have gotten negative 3, 2, and 4, 5 as your points. And as your midpoint, you should have gotten 0.5 and 3.5 as your midpoint. Okay? So for the distance formula, there is a wrap I showed you in class, and I will upload it to the site shortly. But the distance formula is d equals huge square root. Underneath the square root, there are two sets of parentheses. There is addition in the middle, subtraction in the parentheses, and both parentheses are squared. So then you can fill it in multiple ways, but the typical way I'm going to use is x1 minus x2, and then y1 minus y2. Just make sure if you do it in a different way that your x1 and y1 match up. So I used x1 first, subtracting it from the second x value. So I have to use the first y value and subtract the second y value from it. So we're going to use this for 1 and 2. So for 1, we're given 4, negative 7, given 10, 5. There it goes. So I want to label these. I want to label it as x1, y1. All it says is my first x value and my first y value. Second x value, second y value. So I'm just going to plug it into that formula we just wrote down. Actually, let's see if I can get it into the screen. There it goes. So parentheses, instead of x1, I'm going to put 4. Subtract my second x value, which is 10, squared, plus parentheses my y1, which is negative 7, subtract y2, which is 5, squared. Then I'm going to come in here. You do not, hopefully, need a calculator for this. If you do, make sure you're going step by step. We do not want to just put this all in the calculator, because we want an exact value. We do not want an ugly decimal that we have to round to a certain decimal place. So I only want to simplify the 4 minus 10. 4 minus 10 gives me negative 6. squared is there, plus, then we go to our next parentheses. -7 minus 5 gives me -12 squared. I keep going. My next thing I'm going to simplify is the squared. Remember, if you are using your calculator to do some of this simplifying, do not put just -6 squared in the calculator. You have to put the parentheses around the -6 or a negative number. So you should get 36 plus 144. Underneath the radical, you will get 180. 180, the square root of 180, can be simplified. Again, I do want you guys to simplify these radicals. I do not want a decimal rounded. We did a whole unit so we can simplify these radicals to exact answers. So we're going to take 180 and we're going to do a factor tree as far as we can. So what times what gives us 180? If you need to, you can do 2 times what gives you 180 and keep on going down from there. But hopefully, since it ends with a 0, we know that 10 can go into it. So we have 10 times 18 gives us 180. Then we can separate our 10 out as 2 and 5. 2 and 5 are prime, meaning that there is not another number that can go into it evenly besides itself and 1. 18 we can separate out as 2 and 9. 2 again is prime. 9 is not, because itself and 1 are not the only things that can go into it evenly. What I mean by evenly, dividing it by a different number and it giving you a whole number. So for 9, 3 times 3, and 3 is prime as well. So this radical turns into 2 times 2 times 3 times 3 times 5. Now we also learned in Unit 2, I believe, when we did radicals, our index is understood as 2. The reason why, easy way to remember it, if I just did the radical sign and an x, we would know that this is the square root of x. Well, the square root refers to the fact that it's understood 2. So that means we can pair things that are the same in groups of 2. So 2 2s, get married, move out. So I have a 2 on the outside. I also have 2 3s on the inside, get married, move out. And then I have this lonely 5 that does not have another 5 to pair with. So then we simplify what's on the outside, and our distance is 6 times the square root of 5. So that would be our answer for number 1 for our distance. Now pause the video and see if you can do number 2. You should have gotten the square root of 130. Now in number 2, in this case of the square root of 130, you cannot simplify that square root. If you tried to do a factor tree, you would get 13 and 10. 13 is prime because only 13 and 1 can go into 13 evenly. For 10, you have 2 and 5. 2 and 5 are prime. Underneath the square root, you have 13 times 2 times 5, and there are no pairs to bring out of the radical. So it would just simply be the square root of 130. Alrighty. So for applications of the distance formula, we are given this figure off to the right, and we are asked how many feet of fencing will be required if we are trying to fence in this whole figure, aka we want the perimeter. of the figure. So we need to find the distance or the length in between each little point given on the graph. So I am going to go ahead and solve for I'm going to do GF. Line GF is given the points 3, -2, 2, 4, 3. So those are our points. We want to find the distance in between. So here is our x1, here's our y1, here's our x2, here's our y2. Underneath the radical, we are dealing with parentheses, in this case 4, and you can switch it up, 4 minus our x1 squared plus, and again you have to keep consistent of which one you start with. So I started with x2, so I'm going to start with y2. So 3 minus -2 squared. Keep going. I've got 4 minus 3, which gives me 1 squared, plus 3 minus -2. So same thing as 3 plus 2 gives me 5 squared. Then I have 1 squared, which is 1, 5 squared, which is 25. So I have the square root of 26. So similar to the last one, I don't think we can simplify the square root. Let's see if we can. So what is a number that can go into 26? Well, ends with a 6. Is 6 even or odd? It's even. So we know for a fact 2 can go into it. 2 times what gives me 26? 13. Well, that would mean we would have the square root of 2 times 13. There is no pair of numbers underneath the radical where we can move it out. So we would simply have to go back to the square root of 26 as our answer. So the distance between G and F is the square root of 26. So pause the video and see if you can find the other 3 distances. So you should have gotten the square root of 29 in between point F and point E. Should have gotten 5 times the square root of 2 in between E and H. And then the easiest, in between H and G, you should have gotten 5. Now, H to G, you could have just counted how many blocks it took to go to the next point. All of the other lines are not straight, or not laying against the graph paper like H to G. So you cannot count the other ones. Alright. 1 and 2. Remembering that this symbol here means parallel. What line is parallel to BC? Let me change the colors. BC. Well, the only line that even if it was extended, it would never touch BC is NP. If you look at line MP, even if it's extended, well, what is the only line in this figure that would never touch MP? Well, WV. So pause the video and identify the parallel lines for 3 and 4. should have gotten NP and MN. So the theorem that we skipped on the sheet, and that big black dot, I'm sorry I didn't erase it, was just the information I gave you on the figure. So the theorem that I skipped right here where it says triangle mid-segment theorem is what I'm about to explain a little bit simpler than the words given. If you want the words, the specific words, they are there, but I'm going to say it a little bit easier. So if I'm given a figure like number 5, the small line inside of a triangle where one point of the small segment is a midpoint of a line or side of a triangle, and the other endpoint of the segment is also a midpoint, then the small or inside line is half the big or outside line. So what this means is, in this case, the small one or small line is line BC. The big line, in this case, is line KM. So we can show this in two different ways of what I just explained. Either we can take our small one, our small line BC, and to make it equal to line KM, we would have to multiply it by 2. And it would equal KM, or the length of KM. Another way to solve or set these two equal to each other is taking the big line and dividing it by 2 to get to line BC. So I'm going to show you two different ways, or both ways, for 5 and 6. So for 5, let's do multiplying the smallest line. So the smallest line is K, or X plus 15, and that would give us our big line, which is X plus 22. And then I'm going to solve. I'm going to distribute 2x plus 30 equals x plus 22. I'm going to subtract x from both sides, getting x's on the same side, so I still have plus 30. Then I have to subtract 30 from both sides. X equals negative 8, and that would be my answer for x. Sorry, I don't know what just happened. I'm sorry, I'm trying to find it. I don't know where it went to. Lesson 4. There it goes. So, sorry you guys. X plus 30 equals 22 minus 30 minus 30. X equals negative 8. So then we go on to 6. 6, again, our small line is WV. Our big line is going to be LN. So what we need to do is find X. So I'm actually going to use that second method I used, taking the big line, which is X, divided by 2, and set it equal to the smaller line. Well, to get X by itself on this left side, I'm going to multiply by 2. I'm going to multiply by 2 on both sides. X equals X minus 4 times 2. Then I get X equals 2X minus 8. Subtract 2X from both sides. Get negative X equals negative 8. X is still not by itself yet, so I have to divide by negative 1. X equals positive 8 for number 6. So pause the video and attempt 7 and 8, remembering that you can use either methods that I showed you, either multiplying the smallest line or the inside line by 2 and setting it equal to the big line, or you can take the big line, divide it by 2, and set it equal to the smaller line or the inside line. Alright, let's look at 7 and 8. Well, there it goes. So your answer for 7 should have been 12. The answer for 8 should have been negative 8. So if you have any questions about lesson 4, please do not hesitate to let me know via email or remind